Hello guys, I hope you are doing good from where you are. Welcome back to my channel. Today we want to briefly discuss about the chemical properties of alkali metal that I had mentioned before. Last time we had discussed about the physical properties of alkali metals. Today we want to discuss about the chemical properties of alkali metals in the periodic table. So the list, first I'll list the examples of these alkali metals again. The first metal, we have the lithium, we have sodium, we have potassium, we have francium, we have cesium, rubidium, and so on. So first we are going to discuss the distinct chemical properties of this alkali metal, and we are going to list the examples of these properties. So the first property is reducing character. The second point is the reaction with hydrogen gas. The third point is the reaction with nitrogen. The fourth point is the reaction with sulfur and phosphorus. The fifth point is reaction with water. The sixth point is the reaction with halogens. Seventh point is we are going to discuss about dissolution in aqueous ammonia or ammonia liquid. What happens when we dissolve an alkali metals in liquid ammonia? And the last point that we are going to discuss is the reaction with, we are going to talk of the reaction of, the reaction of alkali metals with halides. Reaction with halides. So basically, when we list these brief points on the chemical properties, specifically we are going to start a brief discussion about each point. So the first point was all about the reducing character. The reducing character of alkali metals. The reducing character of alkali metals, when we look at the trend in ionization enthalpy of group 1 elements, when we are moving down the group, the ionization enthalpy decreases. So when the ionization enthalpy decreases, the reducing character of the metal, on the other hand, does what? increase. So therefore, the reducing character is inversely proportional to the ionization enthalpy. The ionization enthalpy we had defined it previously as it is the amount of energy, the minimum amount of energy required to remove an electron from the outermost energy level of an element in gaseous state. Is that the amount of energy required to release an electron in the outermost energy level of an atom in gaseous state. So the second point is the reaction with hydrogen gas. The reaction with hydrogen gas. So basically here we have we are going to have conditions. Condition here we have dry hydrogen gas. Then secondly we have a temperature of 673 Kelvin. So when these metals reacts with dry hydrogen gas, they form a crystalline ionic product. The product formed are crystalline, and on the other hand they are also ionic. So the third point, we are going to the third point. The third point is talking of the reaction with nitrogen gas. So here there is a notice that we must take, that only lithium among the alkali metals can react with nitrogen to form a nitrate. So lithium, the equation for the reaction, lithium reacts with nitrogen to form what? Lithium nitride. So this lithium nitride, as always, nitrogen is valency 3 and lithium is valency 1. So there will be exchange of the valencies here. So that is why we can see when you balance the equation of the reaction here we are going to have 2, put here 2, so that we have 2 nitrogen gas on both sides. So here we, on the product side, we have 6 lithium. Again, on the reactant side, we had what? 1 mole of lithium. So we're gonna put 6 here. So the fourth point, we are done with the third point. We're going to the fourth point. The fourth point is talking about the reaction with sulfur and phosphorus. These alkali metals, they react with sulfur and phosphorus to form phosphates and sulfides. Phosphides and sulfides. So basically the general reaction for the reaction, if I have a metal and I react with phosphorus, I'm going to get metal. Being that phosphorus is valency 2, so that metal will take the valency of that phosphorus. Then if you balance the equation for the reaction, we're going to have that. Same too, when I take that metal, I react with sulfur. Sorry, here we have phosphorus is valency 3, sulfur is valency 2. So here we're going to have 3. So metal sulfide. So here we have 2. So you balance the equation. So these are the 2 general equations for the reactions. The third point is the reaction with water. Reaction with water. What happens when alkali metals react with water? We form what? A base and a hydrogen gas. We form a base and a hydrogen gas. So the equation for the reaction we can use when we have a metal, an alkali metal, when you react with water, you'll form metal hydroxide plus hydrogen gas. This is a gas. So we'll balance the equation of the reaction using the valency method. You count you sum up the total number of hydrogen gas on the product side, and then you balance with the one in the reactant side. So this is the equation before balancing. The sixth point is the reaction with halogens. What happens when these alkali metals reacts with halogens? When these metals react with halogens, they form metal halides. Metal halides. Metal halide. Halogens, we may have an X to represent the metal group, like we have bromine, iodine, and chlorine. So those are the halogens that they are represented by this X. Yeah. So the general equation for this reaction, we can take metal plus will form a metal halide. So it's gonna form the metal halide. Metal halide will form the metal halide. So the next discussion is about dissolution in liquid ammonia. What happens when I dissolve an alkali metal in liquid ammonia? The first observation that we will see is that when we dissolve sodium in liquid ammonia, a deep blue solution is formed. A deep blue solution is formed. First of all, when, for example, when we have when we are given sodium metal will lose electrons to form a cation. When this sodium loses a metal, it will form a cation. The cation and the electrons are elevated by this liquid ammonia to form a deep blue solution which is conducting in nature. So basically we have the general equation for the reaction. When I have sodium, I react with that 1 moles of ammonia. I'll form the cation that they are talking about plus the electrons. So these are the elevated electrons, solvated. These are the solvated electrons. This is the cation that are formed after this sodium has lost the electron. This sodium has lost the electron to form cations. Now the liquid ammonia reacts with the cation and the electron to form a solvated electron, to form a deep blue solution. The solvated electrons form the deep blue solution. So the last reaction is with the reaction with halides. These metals, they do react with halides to form a hydrogen gas as the product concerning the reaction. The equation for the reaction is you will just use the valency method to balance the equation for the reaction. Yeah, exactly. So guys, keep watching my videos. I'll be uploading more and more videos concerning chemistry, Please share this video, it may help one of the friend, and please remember to subscribe so that you get my new uploads. Thank you for watching.